My name is Christine G, and I'm going to be going over this problem today. So we have the shape of the distribution of time required to get an oil change at 10 minutes, and this at some unknown facility, so we don't know where it is. However, records indicate that the mean time is 11.5 minutes, so actually higher than what it's claiming. And the standard deviation is 4.2 minutes. So we're asked to complete these different parts. So for part A, it says to compute probabilities regarding the sample mean using the normal model, what size sample would be required? So that would be the sample size has to be at least 30. So what happens, there's the central limit theorem that is very specific about this, and it's really interesting. If you take many samples, so at least 30 over time, and you get all these means, their distribution will form a normal bell-shaped curve. Um, so that is right for part A. It would also be A. And what is the probability that a random sample of n equals 45 oil changes results in a sample mean time less than 10 minutes? So this is a question that we need to figure out. So first of all, we have some information already. So we have the actual mean is the same as, and we're going to use the same for mean x bar is going to equal the mean, which is 11.5, because that equals the true mean. And then we have the, what we have to figure out is the sample standard, the standard deviation for the particular mean. So we do have the standard deviation, and then we do have n, and this is the sample size. So here, what this is just telling us, this is a formula we're going to need to use in order to get the sample standard deviation. So we know that the standard deviation is 4.2. So I'll just put 4.2 divided by the square root of n, and n is the sample size, which is 45. And then I will take that and calculate that, and I came up with 0.6261. So that is our sample standard deviation, and then we have our mean, and then we want to figure out what is the probability that it is the sample mean time is less than 10 minutes. So here we can go to StatCrunch. So I'm going to go ahead and do that. And let me try and StatCrunch. And then I go into Stat Calculators, and then we're looking for the normal distribution curve. And we had that the mean is 11.5. And then we calculated the standard deviation to the sample standard deviation to be 0.621. 0.6261. And then we want to find the probability that it's less than 10 minutes, the oil change. So here we compute it, and we come up with 0.0082. So let's go ahead and put that in. So if we rounded it 4 decimal places, it would actually be 0.0083. See if that's right. Cool. All right, so now for part C, suppose the manager agrees to pay each employee a $50 bonus if they meet a certain goal. On a typical Sunday, the oil change facility will perform 45 oil changes between 10 and 2. Treating this as a random sample, there would be a 10% chance of the mean oil change time being at or below what value? This will be the goal established by the manager. So we're looking for a 10% chance of being at or below a mean oil change time of a certain, and then we're going to have to calculate the amount of minutes. We're going to use StatCrunch to help us with that. But first of all, there's a couple of things. So we know that there are 45 oil changes. So this is like the sample is 45, just like it was here. So that's good news for us because we can use the mean and then the same, when we use the same sample, we can actually use the same, here it is, oops, sorry about that, the same standard deviation, sample standard deviation, which was 0.6261. So let me go ahead and get that out of the way. So, and then we are looking for the number of minutes. So we have 10% chance. So we have that we can input. So let's go ahead and take a look. So here, this area under the curve, before we calculated it, and it was 0.0082924. But now and that's when the oil change is 10 minutes or less. So that's the area in there. Now we don't know the time, but we do know we want to put in here that it is 0.10. So let's take a look and then we're going to find out. So this area is 10% of the curve. So 10% of the oil changes are done in 10.697621 minutes. So let's see, to one decimal place, so 10.7. So 10.7 minutes. So there is a 10% chance of being at or below a mean oil change time of 10.7 minutes. So, and you saw that that was way over on the left side of the graph. It was, oh, let me see. So it's not very likely at all. So it's over here to the left. And then the mean is at 11.5, which would be right here in the middle. So most of the data, or 90% of the oil changes, are over in this area of the curve. Great. Well, thanks so much for watching. I hope this was helpful. Have a good day. Bye.